Alright, so we're talking about probability of data displays. We've talked about how there are two sets of data. The first set is known as qualitative or categorical data. The key thing here is that it consists of labels and non-numerical entries. Non-numerical means what? Not numbers, okay? So if it's not numbers, it's got to be words, okay? And they're divided into categories. When we're talking about qualitative data, you can't make sense of it with mean. Okay? You can't find the average because you have to add and subtract and do stuff with it. Well, you can't add and subtract words and find the mean of words. So you can't really look at it in a statistics sense that way. This is Miss Pittman.
I'm sorry, Miss Pittman.
Yes, ma'am.
Please send Karen Bell to the office.
Yes, ma'am. All right, so we have qualitative, and then the opposite of qualitative is quantitative. Quantitative consists of numbers. Qualitative is words. Quantitative is numbers. When you're doing a study, so last semester I took a qualitative class, and I had to collect data qualitatively. And so what I had to do is I had to conduct interviews and focus groups and ask people about their feelings, okay? Very wordy type situation. And I had to code it and kind of like you do in ELA where you have to figure out what the theme of the story is. That's qualitative, okay? This semester I'm taking quantitative. It's all about the numbers and gathering scores and data scores and all those types of things. So when I think of qualitative, like an example would be asking the question, what's your favorite ice cream? Because if I went around the room and asked you what your favorite ice cream is, you'd start giving me chocolate, vanilla, strawberry, cookies and cream. All these different answers, the answers are in words, categories. But if I went around and said, what was your test score on chapter 9? Okay, that would be a number you would give me. It'd be quantitative. The way I remember it is quantitative is the same thing as quantity. Like how much is in a box, how much something contains. It's a number. So qualitative is with words. It's more ELA fluffy stuff. Quantitative is more math, numbers, give me the stats kind of a thing. Okay? So those are your two different types of data. So if I look at example 1 here, we're looking at favorite music genres. Would this be considered a quantitative study or a qualitative study? Are you looking at here's your answers down here at the bottom.
Qualitative.
Okay, they're put in the categories: pop, country, rock, hip hop. Okay, those are categorical, so this would be a qualitative study. Okay, so we have this qualitative study of genres of music, and they want to ask us, what is the probability of randomly selecting students' favorite music genre as EDM, electronic dance music? Anybody that your favorite genre of music, electronic dance music?
What is that? Oh, no.
Okay, no. Like just beats kind of a thing, like really weird. Okay, that's what Peyton jams out to at night. Secretly in his bedroom.
Secretly in his bedroom, he's over there.
Yeah.
No, secretly in his bedroom. He's playing Fortnite.
Okay.
While listening to the music.
Alright, so we want to find the probability. Now, last week we talked about probability, and we could set it up in 3 different forms. Tell me, what are the 3 different forms? Fraction, decimal, percent. If I were to set it up as a fraction, how do I set up as a fraction? 1 over what?
Part over
part over the whole. So like the part is, what is the particular event I'm looking for over the total amount of outcomes that are possible. So last week when you did the pi day activity, we looked at the first 100 digits of pi. The total possible number of outcomes was what? You weren't there. What was the total?
Too many.
There was, if we looked at the first 100 digits, how many total possible outcomes were there? 100. Okay? And let's say there were 12 eighths. Okay? Then we will put 12 over the 100. So part over whole. Here we're looking for EDM. That's the part we're looking for. The number of people who did EDM over the total amount of people surveyed. How many people chose EDM? 3. Out of a total of, we would add it all up. There's 6, 5, 7, 4, 3, 5,
30.
over 30, which simplifies to 1/10. As a percent, it would be 10%. As a decimal, it would be 0.10. Those are your probabilities. There's a 10% chance that a student would pick EDM as its favorite genre of music. It's very unlikely for them to pick that. What's the most likely to happen? Hip hop. Okay. All right, looking at this bar graph, we're looking at the different seasons and asking what's your favorite season? Is this a quantitative or a qualitative study?
Qualitative.
What tells me it's qualitative? There's words. Okay, so now we want to find the probability of students choosing fall. So we're looking at fall over the total. How many students chose fall? 5. I have a total of how many students? Which simplifies to 1/4. Which as a percent is 25%. And as a decimal is 0.25. Pretty easy so far, right? And straightforward. Here we've got a box and whisker plot. The box plot represents shoe sizes of students in class. Is this a quan or a qual? It's a quan because shoe size is a number. Okay, we can actually do some math with that answer. And we talked about the different parts of the box plot. We talked about how this is the minimum, this is the maximum, this is the median, this is Q1, this is Q3. And how much does each section, what percentage does each section represent?
5%.
So between the minimum and Q1 is 25% of the data. Between Q1 and the median is 25% of the data. Between the median and Q3 is 25%, and then 25%. So if we want to know what's the probability of selecting a student whose shoe size is greater than 7, how many sections are greater than 7?
3 would be 3.
Here's 7, so it'd be 1, 2, 3, which is a total of 75%. What is the likelihood? It's likely. Good. What is the probability of randomly selecting a student with a shoe size less than 8?
50%.
Well, here's 8. Less than, there's two sections, 25 and 25, give me
50%.
50%. What's its likelihood?
It's like equal. It's a good average and then
Equally likely. Good deal. Alright, I want you to do 4 and 5. You're the teacher. Your friend says the probability of randomly selecting a student who has a pet bird is 15%. Is your friend correct? And then I want you to do number 5 of find the probability of randomly selecting a student who has a pet dog or cat.
we're number 5 coming around it.
Georgia Pittman, please come sign out. Georgia Pittman.
Alright, was your friend correct?
Yes.
Yes, finally, our friend. They're right. It takes them forever to be right, and they're finally right. Okay, so it was 6 over 40. Converted to a percent gave you 15%. Okay, your work should have been explanation enough. So what was the probability of a pet dog or cat? When it says or, what are we doing there? We're adding it together. So we had 9 for dog, 8 for cat out of 40, which is 17 over 40, which gave me a percent of
Approximately 40.
or 42.5% is what you get exactly, right? Questions on how to do any of those? No? Okay. Here we have a circle chart, circle graph, or we call it a pie chart back in my day. I don't know when we shifted it to call it a circle graph, but anyways, you're looking at occupation interest. Is this a quantitative or a qualitative study?
Quan.
What tells you that it's quan?
There's numbers and there's error in the chart.
But what are the answers? What is the interview about?
It's about the skills and jobs.
It's about the job type. This is how many people picked that number. But the answer was not a number. The answer was a category. So this is a qualitative study. The numbers kind of throw you off. So you have to be close and ask yourself, what is the question? What is it asking? What is it looking for? So what is the probability that a randomly selected student is interested in healthcare or education? So we're looking at health and education out of the total amount. So we have healthcare, we have education, out of a total of 50, which gives me 14 out of 50, which gives me a percent of 20%. Questions on that one? Alright, we just got 2 more problems. And then we're done. Alright, so on the back here we have another box and whisker plot. And it represents the heights of a baseball players and softball players. Is this going to be quantitative or qualitative? We're talking about height. Is height a number or a word? It's a number, so it's going to be what type of a study? Quantitative. All right, we want to compare probabilities. Well, if I'm comparing, I need to know the 2 different probabilities in order to compare something. So I'm going to have to find the probability for the baseball and for the softball. And we're looking for a team who is taller than 66 inches. So our event here is what?
Finding the players that are taller than 66 inches.
Taller than 66 inches, okay? So if we're looking at the baseball team, what percentage or how many sections are taller than 66 inches?
75%.
Because here's 66, so I have 1, 2, 3 sections, 3 out of 4 sections, which is 75%. What's the likelihood of that happening? Okay. And then we want to find the probability for the softball player.
25%.
Well, there's only one section. Here's 66. There's only one section taller. So 25%. So how do the probabilities compare? Who's more likely? So all you would have to say is a baseball player has a greater possibility of being 60 inches, or being taller than 66 inches, right? And then there's our comparison. In our second box plot, we're looking at wait times of 2 amusement parks. So you could say we're comparing Universal to Disney World. Okay? 2 different amusement parks. Part A says compare the typical wait times for each amusement park. This is a key word here, typical. When we're talking about statistics, typical can mean that we're either looking at the mean or we're looking at the median. We have to use what we have. We have a box plot. Which one of those central tendencies can we use, or can we find using a box plot? Can we find the mean or the median? Or can we find both? Okay, well the box plot,
Median.
why can't we find the mean?
Because they're, yeah.
So in order to find the mean, you have to add all the numbers. Do we have a list of all the numbers in the data set? No, we don't. But what we do have is we do have the median, or the middle. Now if this was a dot plot, could we find the mean? Yeah, because then we would have every point in the data list. But because we don't have every point in the data list, we can't calculate the mean. So we have to find the median. So we want to compare the median of each amusement park. So in part A, what's the median?
45.
A 45-minute wait is the typical wait. And Part B, what's the typical wait? 75 minutes. Based off of that, who has the longer wait times? So which park would you rather go to? Part A, right? Part B says compare probabilities of a wait time longer than 45 minutes. So if I look at Park A, what's its probability of waiting longer than 45 minutes? There's two sections after 45, right? Which gives me 50%. In Park B, good. So you have a greater probability of waiting longer in Part B than you do in Part A. So if you had to decide if you're going to Universal or Disney, you'd want to. No, this is Universal. This is Disney.
Universal is better.
All right. So now, when Universal gets that new land that opens in 2 months,
Oh yeah.
it's gonna. Those wait times are gonna skyrocket.
I heard it's like expensive.
Universal.
Yeah.
Yeah.
It's a
All right, so that's chapter 10. You need to make sure that you review theoretical and experimental probability. You need to make sure you review likelihood and all those things.